And we're back. Welcome back and happy Tuesday. Today, we will go over a clustering example. But before we begin, some administrative bits. The final exam for this class, scheduled period, will be Thursday, the 6th of May, between 10:30 a.m. and 12:30 p.m. During this period, each of you will be giving a presentation. It might be less than 8 minutes. I have to recalculate from the roster. And you will be required to submit your presentation slides the night before on the 5th of May at 11:59 and 59 seconds p.m. on the course Blackboard. The final project itself will be due, handed in electronically via Blackboard, Friday, the 7th of May at 5 p.m. It's important to note this on your calendars. It's 5 p.m. and not 11:59, 59 seconds. I will not accept late work. All submissions are via Blackboard. Do not wait till the last minute. Do not email me anything. And when you submit, you should submit a link to a zip file that you've put on cloud storage. Make sure you follow instructions. So why don't we begin? So congratulations. You have developed a store. And in this store, it's packed full of customers. But as any good merchant wants to know, who are these people? You want to understand more about your customers. Because if you can understand or perform what's called sense making from your customers based on their purchasing behavior, there are a lot of things you can do, including forecasting, including staffing, including perhaps trying to get them to buy other related products. So let's imagine you went to a friend of yours who took data analytics with Dr. Holness and bing, had a bright idea. I remember when he taught his class, he said, birds of a feather flock together. So if you're going to describe the behavior of your customers, how about if we lump together customers that behave similarly into groups, and then we look at those groups, i.e. birds of a feather, flock together. So let's take a look at so-called similarity-based methods, and we talked a little bit about this during the semester. Similar how? Well, when we describe a customer, we use feature space representation. One of the examples we gave was customers to a bank as described by a two-vector, namely their salary and years in residence. So here we have a data set. Let's say your first customer at $70,000 annual salary and 7.5 years in residence. So we end up with a point in feature space. Now, of course, if we can do this in 2 dimensions, we can do this arbitrarily in D many dimensions. And so therefore, when we think about a point in D-dimensional feature space representation, we have our first feature for our jth data point, xj1, and we have our D feature for our jth data point, xjd. So each one of these D many dimensions represents a single feature that collectively form the attributes that uniquely define the jth customer. So we can absolutely do this in D dimensions. Now, of course, this flock together. How are they similar? And so we can measure similarity by computing the distance between points in feature space. Now, clearly, I'm drawing it here in 2 dimensions because that's easy to visualize on the slide. But regardless of how many dimensions we had for our features or vector representations of our customers, we can certainly measure the distance between them. And so in this case, we might use Euclidean distance. They're perfectly fine. It's just the square root of the sum of the squared differences between each of the features for the respective vectors between which we're measuring the distance. Okay? So we can absolutely measure this similarity, this flocks together between customers expressed as feature vectors. So let's take a look at how we group them. We talked about Lloyd's algorithm and kmeans clustering earlier in the semester. You select some number of groups K. These are your clusters that you desire. Now, K can be 2, 3, 4. For K equals 1, it's not very interesting. It's just all your data. And we name these clusters S1 through Sk. And each one of these clusters is going to be a set of points. Now, each cluster is going to be represented as a center. Call it center point. And typically, this is formed as the cluster's mean. It's sort of the notional middle among all of the records or customers or points within that cluster. And so this center point or cluster center is going to be representative of those data points that are in the cluster. So you start out with some number K that you select at the beginning of your algorithm, and that's going to be the number of groupings of clusters that you desire, and then you randomly initialize some cluster centers. So each cluster center, because it is the mean among the set of points within the cluster centers we call mu are also going to be in D dimension. So we have our clusters, mu1 for the first cluster, mu2 center for the second cluster, up through and including mu big K for the kth cluster, where for the ith cluster we have mu I1 through mu ID. So our cluster centers are also in D dimensions. So how do we compute these cluster centers? Well, we take some number of data points. Let's imagine M many in a particular cluster, the ith cluster. We simply take the mean of the first feature for the data points in that cluster. That's the cluster center for its first feature, cluster center. And then we take up to including the dth feature, the mean, to make the cluster center. And so here we have mu I1 is the mean of the first feature for each point in the ith cluster. Mu I2 is the mean of the second feature for each point in the ith cluster. And mu ID is the mean of the dth feature for each point in the cluster. And so that's how we compute it. So let's take a look at the algorithm for doing so. And this is Lloyd's algorithm, which we talked about. And you start out by randomly picking your cluster center's mu, just randomly assign them. Then you go through all of your data points. You randomly assign them to each of K mini clusters. So you go through X1, X2, X3, and it's like flipping a K-sided die. And whichever number 1 through K shows up on that K-sided die, you assign it to that particular cluster. So then we iteratively minimize this cluster objective. And what does this cluster objective say? Well, let's take a look at this. So we have a double summation, and on the inner summation, you'll see each of the data points X that are in the kth cluster, little k. And so what do? We take the magnitude of those points, the square of the Euclidean distance, and we sum all of those differences between each data point in the kth cluster and the cluster center, mu sub k. And we do that for the first cluster, the second cluster, up to including the kth cluster. So what this says is that what is the distance between each point in a cluster, and then you sum those distances over all the clusters. And so you start out with your random assignment data points to the clusters, and then you iteratively minimize this cluster objective. It's a compactness objective. You start out, once you've made your assignment, you fix your assignment, do not change it, and you compute the centers. That's step one, update your centers. And so the new value of the center is just the mean of each of the features within that cluster, starting with that random assignment. So you get a set of mu k's for each of the big K mini clusters. And then you go to the second step, which is to now fix your mu values, don't change them, and then you reassign points to clusters. How do you reassign them? You reassign the point to that cluster whose center it's closest to. So for all of your xn in sample points, you're going to assign it to cluster K if it is closest to mu sub k. So once you do that, your assignment changes. Then you fix your assignment and you go back to step 1 again and update your cluster center. And each time, your expression for this inner summation is going to get smaller and smaller and smaller because of this nearest center criterion in the second step. So once you update your assignment of points to clusters based on the closest center, you then go back and update the value of the center. And then once you do that, you fix the center and reassign. So you go from step 1 to step 2, 2 back to 1, 1 to 2, and you alternate back and forth until you have no more changes to the assignments. And if there are no more changes to the update for the assignments of points to clusters, then your means, mu sub k, your cluster centers, will stay fixed. All right, so that's our Lloyd's algorithm. So then once you perform your clustering, the question then, how did your algorithm perform? What were your clusters? And that's where you're going to use now descriptive statistics to understand all of those data points that are in the clusters or groupings that you result when Lloyd's algorithm converges. And you also decide upon a name. What are you going to call your groupings? How did the performance change if you modify certain parameters, like the number of clusters or maybe the feature space representation? That will impact the geometry of your data set and therefore the clusters. All right, so let's take a look at this in Matlab. Now, of course, we're not going to implement Lloyd's algorithm. We're just going to use Lloyd's algorithm implementation, namely k-means clustering, that's in Matlab. And so the particular one we're going to use is we're going to use this version of k-means that returns 2 return values. The first return value, IDX, is going to be the indices associated with the data points that you give it, and the indices are going to be marked as which cluster you belong to. So suppose if you have a data set and you have your x1 vector up to your xn vector, and this is going to be in CSV format. So now when you perform the clustering, IDX, let's say you had a cluster of 2, k equals 2, it's going to say, okay, well, this is my first data point, my second data point, up to including my nth data point. Now, IDX is going to have a 1, let's say that belonged to the first cluster, maybe the second one, x2, belonged to the second cluster, and maybe the nth one belonged to the first cluster. So then what IDX is going to contain is the cluster identifier associated with each data point in kind. So this is for data point 1, belonged to cluster 1, data point 2, belonged to cluster 2, data point n, it belonged to cluster 1. And so then C is our set of centers, and C, if you specified 2 clusters, C is going to have center 1, mu1, and center 2, mu2. And of course, that's going to be in D dimensions, where that D dimension is the same D dimensionality as our input space representation, our feature space, because the mu's live in the same feature space as the vectors. Okay, so let's take a look at this implementation and the types of things that we can do with it. So I will meet you in Matlab. So we're here in Matlab, and I have a couple of routines. I'm going to cluster some fictitious loan information. I have a plotting routine, plot 2D data, and that's just going to plot my loan data. And the horizontal axis is going to be salary in units of 1,000, annual salary, and the vertical axis is going to be the years in residence. And so here, I start out with my loan data. I read that in, and I set k, number of clusters, equal to 2, and I go ahead and I plot my historical data. So let's try out this plot of historical data before we run k-means clustering. So let me run that, and when I run it, it's 1,000 examples. Let me make that a little bit bigger. And so along the horizontal axis, we have salary in units of 1,000. And on the vertical axis, we have years in residence. And so each one of these points represents a customer for a fictitious financial institution. And what we're setting out to do is cluster them. So that's my original figure for all of the data points. And then we're going to run our cluster analysis on it to take a look at the natural groupings if we were to put these in two groups using Lloyd's algorithm based on proximity to a center. So now what we're going to do is we're going to call kmeans. And after we call kmeans, we get back indices and we get back centers. So let me continue. So now I have my indices array, and you notice that's 1,000 rows because I have 1,000 data records. And then centers, I have two clusters, so it's going to be 2 rows. And it's 2 dimensions, so we're going to have 2 columns. And so now I go ahead and I search through my indices for those positions in the indices where I have cluster 1 and cluster 2, and they're going to give me indices that I can use in my data table that I read in order to pull out those vectors corresponding to cluster 1 versus cluster 2. So here I call that group 1 data. I take my historical data, my entire record that I read in CSV, that table, or that matrix, and I go ahead and I use those indices that I found that belong to group 1 and group 2. Those are my clusters. That's my actual set of data points that are in cluster 1, group 1 data, and cluster 2, group 2 data. Now you could call this S1 and S2 to be consistent with the PowerPoint slides. So now after that, I go ahead and I now plot in different colors the different centers for my 2 groups, and then I take the center and I plot it as a triangle in bold font. And so I have here my plot for group 1 vectors, and then I have in line 29 plot the center for group 1, and then I have my plot for the data vectors in group 2, and then I plot the centers for group 2. So now after that, I get my groups, and I want to compute some summary statistics about the 2 groups. I plot the mean, the median, the variance, but I don't really print the variance, but I plot or print out the standard deviation. So I take the mean, the median, and standard deviation of group 1 cluster data points and do the same thing for group 2, and I print that out. So let's take a look at my graph. Let me continue here. And we'll look at the graph. So let me bring up figure 1. And let me bring up figure 2. Why don't I run this thing all the way through so that both figures come up? Let me do that. So let me save. And let me run the whole thing. So figure 1 is my original data, and figure 1 contains my data set. Figure 2 contains the same data set, but I'm coloring them based on the clusters. And so I have one cluster I'm coloring blue, and the other cluster I'm coloring red, and I plot as a black bold font triangle the centers for one of the cluster, the blue cluster, and the center for the red cluster. So I see that, and I say, okay, well, maybe I take my blue group and I say those are the people who are, maybe they're recent college graduates, and then the ones in the red group, I might call that the long-time mid-career professionals. And so by grouping together your data, what can you do? You can now give them a name, and then when you decide that somebody, a new customer, belongs to one of the two groups, you can maybe pitch different products to them based on their profile as described by membership to one of these two groups. And so this understanding of your customers can be achieved by doing cluster analysis. And this is just an example. Now, of course, you can see for this cluster, there's a lot of data points that really don't look like they belong to one group or another. They're sort of in the middle, but because you told Lloyd's algorithm partition into two groups, it did that for you. So let's see, maybe it's more appropriate to partition into three groups instead of the two groups. So let's try that out. So let's try clustering with three groups. Now, it's the same code, only instead of two groups, we have three groups. So when I look at my indices, I find the indices where the cluster is 1, 2, and 3. I partition my data to get the groupings of all those data points corresponding to group 1, 2, and group 3. So then when I plot coloring my data based on this group membership, group 1, 2, and 3. All right. So only in this example, I'm not plotting or computing the summary statistics. But let's run this nonetheless and see what we get. So I run this, and when I bring it up, figure 1, that is my original data. It did not change. It's the same as what we had when we had k, the number of clusters, is equal to 2. But the interesting part happens when we color our data based on the clusterings. Now we sort of stratified or chopped up our data into more discernible groups. Now we have the red group and its cluster center. We have the blue group and its cluster center. And we have now this green group, which was some of the subpopulation of customers from the former red group and blue group when we had a cluster of k equals 2. So what do we have here? So now with this, we can say, okay, well, the recent college graduates, based on their student loan and annual salary, their annual salary and years in residence, that's the red group. Then we have the long-time residents that have maybe a higher salary, or mid-career professionals, they have a higher salary, and they have maybe more years in residence. And then we have the in-between, right? They're not quite mid-career, but they're certainly not recent college graduates. Maybe they're working professionals that are straddling between the two. And as we see from this clustering, they're a lot more compact and a lot more descriptive of what's in your data. So now you can be more specific and with specificity target different customer groupings. And when a new customer comes along, based on how close they are to which center, you can say, aha, you're not a recent college graduate, you're not a mid-career professional, you're in this green group. So we're going to pitch certain incentives or programs to you or products. Okay, so that's what you can do with cluster analysis. In real examples, you can make sense of your customers to better drive your business and understand who your customers are much, much better. Okay, so with that, let's go back to PowerPoint. I will meet you in PowerPoint. So we're back in PowerPoint, and this ends our example of using cluster analysis to understand your customers. And so there are many other variations you can have on the distance measure used. We defaulted with Euclidean, but there's more than Euclidean, and these have different utility based on all sorts of aspects of your data set that we'll get into in another meeting. So that's all I had for today. With that, we'll end there. And as usual, please stay healthy, stay safe, and I'll see you all on Thursday.